7.118. This is another integration by parts problem where we're going to have to do it twice and again solve for the unknown integral here. So we start off with an integral of e to the 3x times cosine of 4x dx. So going through Lipit, again we're going to let u equal the exponential part, e to the 3x, dv is everything else. We differentiate u to get a 3e to the 3x dx. We anti-differentiate v. Antiderivative of cosine of an angle is sine of the same angle divided by the derivative of the angle, and that's where the 1/4 comes from. Okay, so we set this up now, our first integration by parts, that the original integral now is equal to u times v, so that's a 1/4 e to the 3x times sine of 4x, minus the integral of v right here times du. The 3 and the 4 come out in front as a 3/4, and then we've got an integral then of e to the 3x sine of 4x and a dx. Now again, this new integral isn't any easier to evaluate than the last one, so we're going to have to do integration by parts a second time. So we're going to let u once again equal the exponential part of that function, the e to the 3x. dv is the sine of 4x dx. Differentiating u, again, we get 3e to the 3x dx. V now, antiderivative of sine of an angle is cosine of the same angle divided by that 4. So there's our negative 1/4 cosine of 4x. So here's where things get interesting. The original integral, the same one that we started with right up here, is equal to, and we've got this original u times v term, the 1/4 e to the 3x sine of 4x stays here. There was a minus 3/4 in front of that integral, and that stays here. And now in brackets, trying to evaluate this integral, we go with our new u times v, which is a negative 1/4 e to the 3x cosine of 4x, minus, originally, the integral of this v times this du. So that negative 3/4 is going to get pulled out in front, and because that was negative, the minus in front of this integral now becomes a plus. And then we've got the integral of e to the 3x times the cosine of 4x dx. This is the key here. That's the exact same integral as the original one that we were trying to evaluate up top, so that's where the solving for the unknown integral comes into play. We distribute the negative 3/4 out in front here and get this mess. Now we've got a plus 3/16 right here from that times that, and the negative 3/4 times the positive 3/4 here gives us a minus 9/16 times the original integral. So we need to get this term and this term combined. So we take this one out of the right-hand side and we add it back to both. So we're going to add a 9/16 times that integral, once on the right and again on the left. These two are opposite, so they'll cancel. Remember that the coefficient in front of this integral right here is a 1, or 25 over 25. 16 over 16, which will add to 9 over 16 to get 25 over 16 times the original integral equals this large binomial right here. Then we just need to get rid of that coefficient and we're all set. So we'll multiply both sides by its reciprocal and get that the original integral is equal to 16/25, the reciprocal of that coefficient, times this big binomial right here, and then we threw on the plus c for good measure. Beyond this, it's just a question of taste in terms of what you would like to do. It seemed a little bit too nice to pass up with a 16 in the numerator here and the denominator here, so I went ahead and distributed the 16/25 to each of those terms there and got a 4/25 e to the 3x sine of 4x, plus 16's cancel, that was a 3, sorry, a 3/25 e to the 3x cosine of 4x, and a plus c. The only other thing I think you maybe could have done there would have been to factor out a 1/25 or an e to the 3x, but as I said, that's all semantics at that point. So, sorry, didn't realize you couldn't see that. So that's where we're at the very end of that one there. A 4/25 e to the 3x sine of 4x plus a 3/25 e to the 3x cosine of 4x and plus c.